I'd like to continue our review of circuits from last year. In our last review session, we talked about how voltage came from the batteries, resistance was a property of the object we're powering, and then current is determined by those two. So current is the dependent variable, and the voltage and the resistance are the independent variables. We saw a direct relationship and an inverse relationship for voltage and resistance. So for a normal circuit, we pick a light bulb with a certain resistance, a battery with a certain voltage, and we get a certain flow of current. That current also determines the power, and the power determines how much energy we use per second. Today I'd like to remind you of circuit types. So we have two main types, series circuits and parallel circuits. Hopefully you remember that a series circuit is a circuit in which there is only a single path for the electrons to follow as they move through the circuit. So every electron has to pass through resistor 1, resistor 2, and also resistor number 3. Series circuits are usually used for times where we're hooking up a resistor in such a way that it's designed to limit the flow of current to a certain object. So here we have a speaker, and to prevent the speaker from getting too much current, we have a resistor that we hooked up in series. If we hooked it up in parallel, this resistor would do nothing. Okay, so anytime you want to limit the current, you want to use a series circuit. Here is another example of a series circuit where we're going to use a resistor to limit the amount of current reaching an LED. Okay, so one use of a series circuit is to limit current. Another use of a series circuit is for controlling the circuit. We want to make sure that switches are always hooked up in series with the thing we're trying to control. If the switch is not in series, it's not going to affect the thing we're trying to turn on and off. So here's an example of a circuit that has 2 light bulbs and 3 switches. Since all of these switches are hooked up in series, turning any one of them off will shut down the entire circuit. I want to make sure you realize that if circuit 3 is off, that does not mean that we will get a flow up until the point of circuit switch 3. When this switch is off, that means no electrons can move onto that switch, which means no electrons can move out of the light, which means no electrons can move anywhere. So any of these switches being set to off shuts down the entire circuit. Okay, so let me show you how you deal with a series circuit. Step 1 is you get your total resistance. So you would add up all 3 resistors because the electricity has to pass through all 3 of these. Every electron goes through all 3 resistors, so every electron is going to face 16 ohms worth of resistance. Step 2, you find the current by doing the total voltage and the total resistance. 32 volts, 16 ohms, means 2 amps come out of our battery. Since there is only one path, 2 amps must flow through all parts of the circuit. Step 3, we get the voltage at each resistor by doing Ohm's law 3 different times. So for the first resistor, we use 2 and 6, and we get 12 volts. At the second resistor, we would use 2 as our resistance and get 4 volts. And here we get 16 volts. make sure you realize that these voltages must add up to the total. In the battery, the electrons gain 32 volts. They lose 12 volts here, 4 volts here, and 16 volts here. They must lose all the energy that they were given by the battery. All right, so way the test is to make sure that your voltages add up to the voltage of the battery. They lose the most voltage when going through the toughest resistor. They barely lose any voltage when they're moving through a very easy resistor. Okay, for parallel circuits, we have multiple paths that the electrons can follow. Parallel paths are used when you don't want one object to affect another. So each of these light bulbs are on their own independent path. Some electrons will follow this bottom path, and some electrons will follow the upper path. You'll notice that the electrons coming out of the battery will be the sum of the current in the bottom path plus the current in the top path. Not every electron goes through path 1, and not every electron goes through path 2. But added together, they should total the electrons that come out of the battery. Notice the switches here. Switch 2 will control just bulb 2. Switch 3 will control just the bulb in the upper path. And switch 1 is designed to control both. If switch 1 is off, both lights are off, regardless of what their individual switches might say. Okay, so what are the steps to doing a parallel circuit? In a parallel circuit, since each path is independent, each path gets the full voltage of the battery. So if the electrons gain 8 joules worth of energy in the battery, they're going to lose 8 joules per coulomb in each of the individual paths. Each path is like it's connected directly to the battery. So step 1, all voltages are the same. Step 2, you can now get each individual current. So to do current 1, you do voltage 1 divided by resistance 1. And we would get 1 amp passing through the top part of our circuit. We could do the same thing here and get 4 amps. We could do the same thing here and get 1.33 amps. You add them all together and you can get the current that came out of the battery. If you wanted to find your powers, and we could have done the same thing with our series circuit, we just do the current times the voltage. So for the top light bulb, we would get 8 watts. For the second light bulb, we'd get 32 watts, and so on. You just multiply the individual current by the individual voltage. If you want the total power, you do the voltage of the battery, and you do the current that comes out of the battery. Okay, so this is how we attack a parallel circuit. If you want to find the total resistance for a parallel circuit, you add the inverses of your individual resistances. More resistors actually lower the total resistance because more resistors mean more paths for the electrons to follow. They make it easier for the electricity to flow through the circuit. So you would do 1/8 plus 1/2 plus 1/6. When you get your answer, don't forget this is the inverse of the total, so you have to take the reciprocal of that answer.